Okay, so the next thing I want to review is pointers. And to really understand what a pointer is, we have to take a step back and understand what a computer actually is and how it works. So in C and C++, depending on what you took your COP 2000 course in, we have variables. And variables are stored in your computer's memory somewhere. And we don't really talk about it because they happen automatically. You create a variable, it goes in your computer's memory, and you get to use it as you please and never really understand or at least need to understand for automatic variables. That's their name. I should define it before I use that term. Automatic variable means you don't have to really define an area of memory for it or anything. You just say integer, my int, or string, my name, or what have you, and it just automatically goes into existence. Your C++ compiler knows how to create the instructions to put that in your computer's memory, and everything's done for you. But when you start to work with pointers, what ends up happening is those variables are still automatically created, but now you're going to the next level down and you're saying, okay, well, you've created that variable and I gave it the value, say we're working with an integer, I gave it the value 8, and we'd put that value 8 somewhere in memory, and up until that point you've been able to just use that variable and the computer automatically knows how to look in that area of memory. But now what we'll have to do is actually understand the memory addressing setup when we start to use pointers to look into that ourselves. So enough rambling on about that. Let's actually define what makes up a modern computer. So and actually this is, I shouldn't say modern computer, that's a little bit misleading. This is all computers. To be a computer, you really have to have three things. You have to have a CPU. And I apologize ahead of time for my writing. I'm using an old cheap bamboo tablet that I have, and it's not the greatest, and I'm not very good with these things anyway to begin with, and I don't have the greatest graphics program in the world here anyway, so I'll do my best with the writing and make it legible. So, okay. The three things we have are our CPU, we have our memory, and when I say memory, I mean our RAM. So if you've ever heard the term before, RAM, that's what we're referring to. And then we have our storage. Okay, so the CPU is it stands for Central Processing Unit, and that may or may not make any sense to you. And so what the CPU is typically you have your Intel processor. You've maybe seen the term Intel inside. Another company that makes them is AMD. There's a company that makes them for cell phones called ARM. And if you've ever heard any of those names or companies, then that's what they produce. That's what they're doing. They make a Central Processing Unit. And we'll come back to that in a second, exactly what that is. We have our computer's memory, and when I say memory, I mean our RAM. And I'm sure a lot of you had to take in high school or at some point in your life some sort of computer class where we learned about bits and bytes and RAM, and so that's what we're actually going to be working with the most when we get into pointers is our computer memory, our RAM. And so throughout the years there's been different types of RAM, but you don't really have to know about or worry about any of that. Just know that there's some form of general memory available. And then we have our storage. And so these three things make up our computer. And so when I say storage, I'm talking about a hard drive or solid state drive. In certain scenarios, you can actually run a computer using a thumb drive or an SD card. And but typically most computers are going to be running off of some sort of hard drive or solid state drive. If you have a smartphone, which really by most modern definitions is going to count as a computer, because really it has all these three things. It has a CPU, it has memory, and then it's going to run off many times some sort of what's known as flash memory or SD card. So we have our storage. We write our computer program and we compile that into some sort of executable file that we start and run. And so that's the first stage. That sits in storage. And then so in, say, we'll just refer to Windows. We double click that program and it starts. It goes from our storage into our memory. And then what happens is pretty much for the life of the program, or for the simple programs that we're using anyway, we just go back and forth between memory and CPU. So every time we make a data structure or data type, as we went over in the previous video when we went over structures, we have our data structure is stored in memory, and then when we talk about algorithms, those are executed in our CPU. So let's talk about memory a little bit deeper. So there's two things to know when you're talking about memory. Typical in and let me scroll down a little bit here so we can have a little bit more room to work with. Okay, so we work with memory, and we buy a computer and it's rated in gigabytes, and so you might have your computer might have 2 gigabytes or 4 gigabytes of memory, and that's actually structured in a very certain way, what's known as memory addresses. And so every single bit of memory, we can kind of sort of draw it as a diagram, and that's usually the easiest way to represent it and understand it. Okay, so right here we have what's known as 4 bytes of memory, and you've probably heard the term bits before when you hear people talking about a 32-bit computer, 64-bit computer, and what we do is we divide, or I should say, we group that from bits into the next logical unit, which is a byte, and a byte is 8 bits, and if you've ever worked with, in your COP 2000, a data type for a single alphanumeric character, that's 1 byte of memory. And so these have addresses, and so we'll start, this is address, let's actually start from 4, let me rewrite that. And actually let's start with a higher number, because typically your computer has so much RAM, you're not going to get, some of these low addresses. So let's say 1000, 1001. Okay, so we have our memory, and then we can draw some arrows showing that it goes this way for a long time and then this way for a long time. And so that's actually what happens. And so say we create a program and we say int I equals 3. So what actually happens is your computer then inside memory puts the number 3, so we've declared an integer, and we're putting it in a memory location, and it's in 1000. Well, when we write a program, we don't see that 1000. What we're primarily concerned with is the value within that. So the compiler sort of takes care of everything and knows that we're in memory address 1000. And what actually happens is, I don't want to get into this too much, but it'll actually when we talk about 32-bit computers and 64-bit computers, it'll actually use up a bunch of memory addresses. So on a 32-bit computer, once we define the number 3, all these next memory addresses are unavailable until 1004 would be the next available address. But don't worry about too much if you don't understand that. But what you really need to understand is that there's 2 parts to a variable, and a struct is basically the same way. We have our computer memory address, and then we have the value within the address. So think about it as your mailbox at home, your actual mail that you get from the United States Postal Service. What's in the mailbox and the address of the mailbox are 2 different things. So say I live on, my address is 701 Main Street. Well, that's an address. That's 1000. But our mailbox, and so we have that marked outside of our mailbox, and then so the Postal Service delivers a letter and say that, oh, well, they deliver a letter that all it contains is the number 3. And so what's within the mailbox is the number 3. And so say I'm the mailman, I have this number 3 in my hand. I have a letter or an envelope I shouldn't say letter because it's really a number, let's say envelope, that we need to deliver. And so we're given the address 1000. So he drives his truck along his route, and then once he gets to 1000, he puts that there. And if he needs to pick up a package, say you put your envelope in the mailbox and you put your little flag up, he comes back and grabs that number 3. So we'll begin with that, and so this video doesn't run too long. Let me go ahead and I'll break this up into different parts. So this will be the first part, just understanding memory and how it works. CPU and storage. CPU we'll get into maybe a little bit later in the course once we do algorithms. You won't need to understand what a CPU is necessarily, just that it executes your algorithms, and it has a tight relationship between the memory. Storage, well, storage is very important, and if you do any sort of file processing, if you write a program to be able to go through a Word file and do something, that's definitely something important. I don't know how much of it we'll get into this course either. Maybe if we have some time near the end, we'll do some file processing. So look for the next video, which will be actually writing some code to work with these memory addresses.